Hello. Hello. Am I audible? Okay. Yes. I'm audible now. Yeah. So good evening, everyone. So hi. Good evening, everyone. I'm Rahul Mohnani, your maths educator. You can use my code RM sir to get the ISC Class 12 subscription. ISC Class 12 Plus subscription. Okay. In Plus classes, we used to take the regular classes, and the entire syllabus is covered. And test series are also given. Along with the test series, we used to discuss the papers also. So if anyone is willing to take the Plus subscription, they can use my code RM sir. Today's topic which we are going to discuss is integration. So in integration there are actually many types: algebraic, trigonometric, and in algebraic also there are subtypes. So today we are going to discuss few subtypes of algebraic integration. Okay, so in algebraic integration there are some types like linear by linear, linear by quadratic, something like that, quadratic by quadratic. Okay, so today we are going to go focus on these type of integrations, and the one which are going to convert into this. There are some integration which will be converting into this type. Okay, fine. So this is the batch that we started on October 6th. Okay, these are the educators. Mohana ma'am is going to take the physics. Manisha ma'am is taking chemistry, and Lakshya sir is taking biology. I am covering maths. Okay, so let's start with the topic. While taking the types, I'll assume that you know the basic formulas. Wherever required, I'll use those formulas. Okay, I'll just mention that formulas beside the questions. So the first type which we are going to discuss, type 1, is linear by linear. In this also we'll discuss a few different type of questions. Linear by linear, it means what? Integration of a type ax plus b upon cx plus d dx. This is a linear function, ax plus b upon cx plus d. How to solve or how to approach these type of questions, we'll discuss that. Now in this, the first question I'm going to take, integration of, let's say, x upon x plus 3 dx. This is a little easier concept. Like here we don't have a constant in the numerator. Integration of x upon x plus 3. So as we can observe, like there is no constant in the numerator. The variable x and x part is also same. So here the common approach that we apply is add the 3 in numerator and subtract the 3 to balance it. This is the first step. I'll practice a few more questions on this on the different type. So this is the easiest one, x upon x plus 3. So as we can see, in numerator and denominator the quotient of x are already same. In numerator and in denominator the quotient of x are already same. We just need to adjust a constant to make the numerator and denominator same. So now if you separate a denominator, over these two terms like this, so now if you see that this is 1 minus 3 upon x plus 3 dx. Now let's separate the integration. We can separate the sign of integration like this. Integration of 3 upon x plus 3 dx. Integration of 1 is x minus this 3 is constant. We take that constant outside upon x plus 3 dx. Now if you know uh, the integration of 1 by x, the integration of 1 by x dx is log x. The integration of 1 by x dx is log x. So over here instead of x we have x plus 3. Over here instead of x we have x plus 3. This. So whenever a linear terms comes in the denominator, whenever a linear terms comes in the denominator, you can take log of that linear term. Okay, that is what the integration is. So here the final answer I'm going to write x minus 3 times log of x plus 3 plus constant of integration c. So the final answer for this particular question is x minus 3 times log of x plus 3 plus c. Right? So here it was very easy to adjust a constant and like that. So in this case the answer is x minus 3 times log of x plus 3. I'll take one more type of this question. I hope this is clear. Only the first thing you need to adjust is 3 and minus 3 here, then separate denominator, then separate denominator and then solve it. Okay, so for one this and this. Okay, now the next one. Again of type linear by linear. In this, let me erase this. For example, we are taking 2x minus 1 upon 3x plus 1 like this. Now this is a little different. Okay, we can see that in denominator the coefficient of x is 3 and in numerator the coefficient of x is 2. What is the strategy to solve these type of questions? We'll always try to create 3x plus 1 in the numerator. We'll always try to create the denominator thing like linear 2 will be created in the numerator. This is what we'll try. We'll try to create linear 2 in the numerator. Okay, denominator will be always created in terms of numerator. Now to make that we'll take 2 common. So when you take 2 common, you will divide each term with 2 in the numerator. This is the first step. Always make this coefficient of x 1. Okay, this 2 I have taken common. So when you take 2 common, this will become x. This will become 1 by 2. To make this 3x, now we are going to multiply with the 3. To make this 3x, now we are going to multiply with the 3. That is our target. Okay, so if you multiply with 3, to manage that, you divide with 3. So 3x minus 3 by 2 upon 3x plus 1 dx. Okay, again try to understand this part. This is very easy. If you are learning this first time, it might be difficult, but actually it is very easy. So the first thing, I have taken 2 outside to make the quotient of x as 1 minus 1 by 2 because we have taken the 2 common upon denominator as it is. Now we want 3x to be in the numerator. Okay, why do we want that? Because it is easy to integrate afterwards. Like we are trying to create that variable in the numerator. So this 3x I multiplied with 3 and divide with 3. Okay, so here we have multiplied with 3 and then divide with 3. So like this it is. Now to adjust this 3 we have written 3 by 2 also. So everything is balanced down. Everything is balanced over here. Now we need a constant 1 in the numerator along with 3x. Let's add this 1. So the next step is 2 by 3, 3x plus 1 minus 3 by 2 minus 1 upon 3x plus 1 dx. Okay, now what is this step? Along with the 3x, I've added 1 and then subtracted 1. This is now we can see 3x plus 1 in the numerator. If you carefully solve this entire part, you will get 2x minus 1 only. If you carefully solve this entire part, you will get 2x minus 1 only. Okay. So like 1 gets cancelled, then 3 divides, and everything after simplifying, you will get 2x minus 1. Now let's simply divide. Now let's divide 3x plus 1 or separate 3x plus 1 over the numerator. So 2x plus 3. I'm separating 3x plus 1 on this numerator. So it will give us 3x plus 1 upon 3x plus 1 minus. Now this is how much? Like it will be 5 by 2 upon 3x plus 1 dx. So now if you integrate, this is 2 by 3. Integration of this will be 1. Then 5 by 2 3x plus 1 dx. Okay. Now let's write the next step. 2 by 3. Integration of 1 is x minus 5 by 2. Integration of 1 by 3x plus 1 is log of 3x plus 1. As I've discussed this with you, like 1 upon linear function, it should be linear only. It should not be any other function. Okay. Linear means ax plus c type, bx plus c type, in that way. Okay, not the sin x, not the cos x. So 3x plus 1 into 1 more 1 by 3. So whatever the quotient of x is, that you have to divide with that quotient. So now this is the final answer. And let's multiply 2 by 3 inside the bracket and see what we are getting. So 2 by 3x minus 2 gets cancelled here. It will be 5 by 9. See, this 2 gets cancelled and 5 by 9 log of 3x minus 3x plus 1 plus c. I hope this is clear. This was the actual question that I wanted to take. This was the easiest one. Okay. In this, the quotient of x and quotient of in numerator and denominator are different. Quotient of x in numerator and denominator are different. So we need to adjust that properly. Okay. After adjusting, we saw that this 3x plus 1 got in the numerator over here. Then we separated, and then like that we have solved. ऐसे solve करना है. I hope you understood how to create this linear, how to change this linear in the different format. This is how you change linear in the different format. Okay. Now this was a linear by linear type. Now I'll take 1 by quadratic type. After that, linear by quadratic. So now we'll discuss 1 by quadratic type. 1 by quadratic type. This is the most important form. It's used in many questions. To understand this or to solve the question based on this, you should be aware with the formulas. Okay, the formulas which are of this category: 1 by x square minus a square dx. Okay, the first one. After that, 1 by x square plus a square. Okay, I want you to remember all these formulas before solving 1 by quadratic type. 1 by a square minus x square dx, like this. So the fourth one, 1 by root of, so in that 1 by root quadratic will be there. So right now we'll focus on these three. I'll just erase this one. This is on the type 1 by root quadratic. So right now we are not discussing. This is 1 by quadratic type. Okay, so you should remember all these formulas, 1 by x square minus a square and all. I'm going to write it over here. Try to remember by the next class. So 1 by 2a log of x minus a upon x plus a plus c. Okay, this is 1 by a tan inverse x by a, and this is 1 by 2a log of x plus a on x minus a. In this, x plus a comes in the numerator, everything plus c. Okay, fine. So these three formulas are there, which you are going to use in the next step, or to solve the questions of 1 by quadratic type. Please note down this if you are watching this session, so that we can go ahead with the next slide. Done. This is just a calculation I'm doing over here. So now let's discuss the questions based on this. We can do this, like if you forgot this type of proof or the questions, I'll take the proof of this question also, first one. Okay, I'll take the proof of the first question, so that if by chance you don't remember the formula, you can go ahead with that proof. Okay, so I'm just trying to prove this first question here on the next slide. Let's take a proof also. Integration of 1 upon x square minus a square dx. Okay. Now this is how you solve it. See, first of all, we'll factorize it. X minus a, x plus a dx. So now these are the two brackets. Now look at the difference of these two brackets. Like, what is the difference of x plus a minus x minus a? X plus a minus x minus a. Difference is 2a. So we'll adjust that 2a over here. 2a, I have multiplied 2a in the numerator and in the denominator. What is the step I have added? I have adjusted 2a in the denominator and 2a in the numerator. So this 1 by 2 I'll keep it as it is. In the numerator I can write x plus a minus x minus a. Okay, this x plus a minus x minus a. Now if you separate a denominator, you will get 1 upon x minus a minus 1 upon x plus a dx. Okay, 1 upon x minus a minus 1 upon x plus a dx. And here if you can see 1 by 2a, integration of first term will be log of x minus a, this thing, and the second term will be log of x plus a. Now if you apply a property of log, you will get 1 by 2a log of x minus a upon x plus a plus c. So this is how we have proved the first property, first theorem, or the first formula. Okay, I want everyone to remember all these three. Okay, the plus is for tan inverse. In the negative also, here it is x plus a. It is exactly negative of the first one. It is exactly the negative of the first one. Okay, so please note all this, and we'll start with the question based on this 1 by quadratic. Fine. So let's see question based on 1 by quadratic. I'll again take the easier one first. Integration of 1 upon 2x plus 3 का whole square minus 4 dx, or instead of 4 we'll write 25. Okay. So 4 we'll write 25. So integration of 1 upon 2x plus 3 whole square minus 25. This is the first thing we can observe. So write the format, the one which you have learned. Integration of x square minus a square dx. This is what we have learned just right now. It is 1 by 2a log of x minus a upon x plus a. Okay. So instead of x in this question, what is there? 2x plus 3 whole square. Instead of a, we can write 5 square dx. So as we can see, it is 1 upon 2a. A is 5. Just have to compare it. You have to compare it properly. Here a is like a square is written, and here 5 square is written. So 1 by 2a. Instead of x, we have 2x plus 3, and the square is already there. Instead of x, we have 2x plus 3, and the square is already there, right? So now if you again apply a formula, so that is 1 by 2a log of, instead of x, I'll write 2x plus 3 minus a upon 2x plus 3 plus a. All after doing all this, you have to multiply with 1 by 2 also. So when to divide or when to multiply with 1 by 2? Whenever the quotient of x is something there. Whatever the quotient of x is there, like 2x plus 3, so you divide with 2. If it is 5x plus something, so divide with 5. You have to divide with quotient of x. Always remember this. This is an important step. So now the final answer I'm writing. This is 1 by 2 and this 10. So 1 by 20 log of 2x plus 3 minus 5. That is 2x minus 2. And in denominator 2x plus 8. So if you want to divide with 2 in this also, that can be done. So 1 by 20 log of x minus 1 upon x plus 4 plus c. This is your final answer. Okay, 1 by 20 log of x minus 1. So this was again the easier one. After this, it will not be in this format. We have to convert in the perfect quadratic square. So we'll do that now. I hope till now is everything okay. Hello, Alankrutha, hi. This is for ISC Class 12 students. You are in which batch now, Alankrutha? Yeah, okay. So let's continue with the next question. Integration of 1 upon x square plus 6x plus 13 dx. Okay, x square plus 6x plus 13. So here we can observe it is of the type 1 by quadratic. Okay, we can observe that it is of the type 1 by quadratic. Now to solve this, you need to first make into the perfect square. So this step I'll explain how to change a function into perfect square, how to change a quadratic into perfect square. So x square plus 6x plus 13. To make this quadratic into the perfect square, you need to make sure that the quotient of x square should be 1. You need to make sure that quotient of x square should be 1. So in this case it is 1. Okay, if it is not 1, then you have to take that term common. You have to take that term common and then make it 1. After it is 1, you have to add and subtract the square of You have to add and subtract the square of half the quotient of x. The square of half the quotient of x. Like what is the coefficient of x? Quotient of x is 6. Make the half of that. Half of that will be what? 3. Half of that will be 3. So you have to add 9 and subtract 9. You have to add 9 and subtract 9. So we'll write like this: x square plus 6x plus 9 plus 13 minus 9. So I've added 9 before 13 and subtracted 9 after 13. So now if you observe, this entire part is x plus 3 the whole square, and this is plus 4. X plus 3 the whole square, and that is plus 4. So let's continue with the question now. The entire question now is 1 upon, this entire part is now replaced as x plus 3 the whole square plus 4 dx. That can be written as 1 upon x plus 3 the whole square plus 2 square dx. Now look at the formula that we have learned. Okay, look at the formula that we have learned. The formula was 1 upon x square plus a square. Is it corresponding the same formula? Yes, it is 1 by a tan inverse x by. This was the formula that we have learned, 1 by x by. So instead of x, as we can see, x plus 3 is there, and instead of a, as we can see, 2 is there. You just have to compare it properly. So instead of x, we have x plus 3. Instead of a, we have 2. A square is 2 square, so a is 2. So let's write the final answer now. Final answer is 1 by a tan inverse x by plus c. Okay, this is the final answer, 1 by a tan inverse x plus 3 by 2. I hope 1 by quadratic type also is okay with everyone. Okay, in the upcoming sessions I'll plan for linear by quadratic and all. Right now I'll just give you 3 more formulas for 1 by root quadratic. This was 1 by quadratic type. Now right now we'll focus on 1 by root quadratic type also. So let's write the formulas that we used in the root quadratic. Everyone please note this formula, similar to these 3. Like these were for 1 by quadratic type. Now we'll discuss on 1 by root quadratic type. Again, that is also important. These are very easy and important questions, and in majority of questions these are used. Right now we are taking the basic one, but in majority of questions we are going to use this one. Okay, so the first formula is 1 upon root of x square minus a square. It is log of x plus root of x square minus a square plus c. Then 1 upon root of x square plus a square. It is log of x plus root of x square plus a square. Okay, and the last one, 1 upon root of a square minus x square. So this is sine inverse x by plus c. Okay, I'll take one question based on this, and then we'll stop after that question. Please note this. I'll give you 1 minute to write this, and then we'll continue with the question. I hope this is done. These are the three formulas in which roots are given. Okay, these are without roots. These are without roots. In this also two log formulas are there and one tan inverse. In this also two log formulas are there and one sine inverse. Remember this properly. Let's take one question and then we'll start. Like integration of 1 upon root of 9 minus 4x plus 1 the whole square dx. Integration of root of 9 minus 4x plus 1 the whole square. This is again the easier one. Only you have to apply a formula. I'll just write a formula and then explain it. Integration of 1 upon root of, instead of 9 I'm writing 3 square minus 4x plus 1 the whole square dx. And the formula that we are going to use is 1 upon root of a square minus x square, because as we can see constant term is in the previous slide. Like first constant term is there, then minus the variable part square, a square minus x square we are going to use. इसमें difference देखना है ठीक से. Here x square variable part minus a square and here we have a square minus x square. So constant term is before and afterwards, subtraction is variable term. So वो इस कैटेगरी में आ रहा है 3 square minus 4x plus 1 का square. Okay, now let's apply the formula. It is sine inverse x. X is 4x plus 1. X का रोल कौन प्ले कर रहा है यहाँ पे? 4x plus 1. Sine inverse x by a. A means 3 here. All we have to do is just multiply with 1 by 4. Okay, all you have to do is just multiply with 1 by 4 because the quotient of x is 4 here. We need to always make sure that we'll divide with the quotient of x. Okay, and plus c. So the final answer is 1 by 4 sine inverse 4x plus 1 upon 3. This is your final answer. Okay, I hope this is clear. Any doubt or anything you want to understand in the next class or wherever, you just comment down in the comment box and let us know wherever you have a doubt, which question you want us to take more. Okay, this will help us to understand in which particular problem or any particular concept you are facing an issue. Okay, and again at the end, if anyone is willing to take a subscription, they can use my code RMSIR on ISC 11 and 12th category. So if you can join the, or you can install the Unacademy application. From there you can enroll the course for ISC class 11 and 12 by using this code. Here you can get a 10% off. So goodbye everyone.